To find an equation for this graph, we first need to recognize that this is a rational function. And rational functions have asymptotes. And the locations of those asymptotes are based on the equation of the graph. So let's find the asymptotes here. So it looks like I have an asymptote at 1 and another one at -1. So I have two vertical asymptotes at +1 and -1, and it looks like I also have a horizontal asymptote at y = 2. Alright, so now we have to kind of work backwards to try to figure out what the equation was that would give these kinds of asymptotes. Alright, so a rational function is a ratio of two polynomials, and you often get vertical asymptotes when your denominator equals 0. So I have to have two places where my denominator equals 0, 1 and -1. So my factors in the denominator will be x - 1 and x + 1. That means my denominator will be 0 at both 1 and -1. And if I multiply those two factors together, I get x² - 1. Alright, so that will get me my two vertical asymptotes where I need them. And then I should try to come up with something in the numerator that will give me the correct horizontal asymptote. And there are three cases for horizontal asymptotes. And the only way you can get a horizontal asymptote other than the x-axis is if the degree of the numerator and the degree of the denominator are the same. In this case, you have a horizontal asymptote at the ratio of the leading coefficients. So the degrees have to be the same, and the ratio of leading coefficients has to be 2/1. Right, so my denominator already has a leading coefficient of 1, so if I make my leading coefficient on top a 2, and the degree has to be the same as the denominator to get a horizontal asymptote anywhere other than 0. And this looks pretty good, 2x² over x² - 1, and we should just double check some points. The only integer point I have in here that I can check is the point 0, 0. So if I plug 0 in here, I do get 2 times 0² divided by 0² - 1, which is 0. So that checks out. And if I had any other integer points, I might try plugging them in just to make sure that I had this right. But this looks like a good formula.